Well, howdy there, Internet students. We're going to start lesson 4.2 today, objective 4.2a, exponential relationship. The graph you're seeing right here is an example of a graph of an exponential relationship. Now, one thing you'll notice right away is it's not a straight line. Exponential relationships are definitely not linear. Here's an example of an exponential relationship. I bought a Super Bowl once that I took it to the top of the roof of my shed and I dropped it on the cement, and then I estimated how high it bounced up, and I found that it would bounce up 3/5 of the way each time for each bounce. And then it just kept bouncing, and every time it rebounded to 3/5 of that height. Okay. So if I started at 10 feet tall, that would be my 0 bounces height. And then what I'm going to do is I'm going to take my calculator, and the way you get 3/5, there's a couple of ways. But one thing you could do is figure out what percent that is, which is 60%. And the decimal for 60% or 3/5 is 0.6. So here's what I'm going to do. Let me clear this for you so you got a nice screen there. But I'm going to start with 10, press enter, and then I'm just going to multiply by, you could just do 3 divided by 5 this way. So anyway, the first time it's going to bounce up to 6 feet high, and then 3.6, and then it's going to continue to do that. So I'm going to let you go ahead and fill in the rest of the table. So you saw how I got the first one and the second one. Go ahead and fill in the rest of it. Round them to the nearest 10th each time. So there's the table you get when you round them to the nearest 10th. Since these are going down in height each time, we call this exponential decay. And you'll hear that word in science often. If it was going up and the numbers were going up, we would call that exponential growth. Okay. What patterns do you see in the table? Well, you definitely don't see a linear pattern. What you should be seeing is that you're multiplying by the same thing every time. And that's numbers 3/5 or 0.6. All right. And no, it's not a linear relationship. Will the ball ever stop bouncing? It will. You'll keep getting an answer on your calculator. You'll never get 0 until it rounds it to 0. But yeah, I mean, technically it will stop bouncing. Now here's how you make your graph. So 0 bounces is 10 feet. 1 bounce was 6 feet. Then 3.6. Now these ones you're going to have to estimate. 2.2. I'm going to guess that's about right there. The 4th bounce was 1.3. That would be about right there. So go ahead and finish that graph. And you should see a curve going on here. This is called an exponential decay curve. All right, let's try another one here. It says you have a balance of $2,000 on your credit card that has an interest rate of 25% each year. If you don't pay off anything for 7 years, how much debt will you have accumulated? So we're going to start with 2,000 at year 0. At year 1, if we don't pay any of it off, we're going to owe that 2,000 plus an extra 25%. Now, when I'm doing a 25% increase, if I wanted to stay the same, if I wanted it to be 2,000 every time, I would be at 100%. And to get that, I would multiply by 1. But I want to be my 100% plus an extra 25%, because that's how much I owe for borrowing it. So I'm going to multiply by 1 plus 0.25, which is 1.25. That'll give me my 2,000 plus an extra 25%. Okay. Let me show you on your calculator how that works. So if I just did my 2,000 times 0.25, that would be 25%. That's 500. I would now have to add that on to the 2,000 to figure out what I owe. Now, what I suggest you do is add on that on to the 100% you owe. So we're going to multiply by 125%, which is 1.25. So what I'm suggesting, and you'll get the exact same answer, is you take your 2,000 times 1.25. So you get a little bit more than 1. You get 25% more than 1, actually. So 3,125, and so on. Round these numbers to the nearest hundredth, because that would show cents. Okay, so go ahead and finish the rest of that table. All right, so here are the numbers I got. You definitely want to pay off your credit card. You don't want to let it sit there, because after 7 years, you're going to owe almost $10,000. This is an example of exponential growth. You should see that you are multiplying by some number. In this case, it's a little more than 1.25. And you also found out that you get the number you multiply by adding what percent, the percent that you are going up onto 1. Okay. If you pay the minimum $50 payment each month for 7 years, you will be able to pay off your debt. How much money will you have paid in total? So now you have to subtract that $50 each time. You could figure that out. I'm not going to spend a lot of time on that one. But to make our graph, so in this one, we start at 2,000. Then we go to 3,125. Now these you're just going to have to estimate. 4,000. Whoop, I missed this. 2,500 goes there. 3,125 goes there. 3,906, so almost 4,000. And then, you'll start to see it slowly curving up. It'll increase faster as we get more years out. All right. Let's try another problem. Mr. Brooke brought two fruit flies to his biology class. He then told his students the flies would reproduce and that the population of flies would about double every week. So Luis and Roberto wanted to figure out how many flies there would be each week. So after 1 week, there's going to be, he brought 2 fruit flies. So after 1 week, the population would double. So there's going to be 4. And then twice that is 8. Go ahead and finish the rest of that. Now what you should see that we're multiplying by 2 every time. So he started with 2. So I just want to figure this out for 10 weeks. And each week we multiplied by 2 again. So to get to 2 weeks, we multiplied by 2 twice. To get to the 3rd week, we multiplied by 2 3 times. And so to get to the 10th week, we're going to multiply by 2 10 times. And I believe that equals 2,048. I didn't actually calculate that, but you can check my work and see if that was right. If it's not, then fix it. All right, so those are just some beginning problems, some introduction problems to exponential growth and decay. Go ahead and you should be able to do your homework now. If you have any questions about it, let me know. Good luck with that.